this. Tough to get going here. All right. So, what is the pattern on number 1? You guys remember sigma notation?
In times 5 or 5n.
Yeah, so those are powers of 5. That's 5 to the 1, 5 to the 2, 5 to the 3. So the notation would be 5 to the n. And then over here you put n equals 1, and how far are we going? 2, 3, 4, 5, 6. You guys remember that? So what this means is you plug in 1, you plug in 2, you go all the way to 6. And not only do you plug them in, you're supposed to add all those two. You're supposed to get the sum of those terms. Plug in 1, you get that. Plug in 2, you get that. Plug in 3, you get that. You're supposed to add them all together. But we don't have to right now. Number 3, find the sum of each arithmetic series described. So there are 3 formulas that we use this chapter. Arithmetic series sum, geometric series sum, and infinite geometric series sum. So maybe I should back up a little bit. We started with sequences, and sequences are just numbers that are like listed out, like 2, 5, 8, 11. This is a sequence, it's just a list. When you get to a series, you're supposed to add them together, like that. So that's the difference. Almost the same thing, but this one you're supposed to add them together. Sequences just have a pattern. You guys remember an arithmetic sequence just has an adding pattern, like you add the same number over and over. A geometric series or sequence has a multiplying pattern, or you multiply over and over. And there's other sequences and series that are not arithmetic or geometric. They just are. They have some pattern. Okay, so on number 3, if we want the sum of an arithmetic series, see where I wrote arithmetic series sum. What do you guys think that n stands for on n over 2? How many terms are, you're going to do? A sub 1 would be the first term in the series. A sub n would be the last term in the series. So, on number 3 and 4, they just kind of give us all those numbers. So you just kind of plug them in. So it's 5 over 2, 0 plus 12. Alright, number 5, find the sum of the arithmetic series described. So kind of the same thing. The only thing that's missing is they don't tell us the last term. So they give us the number of terms. They give us the first term is 7. But how do we find the last term, nth term? Alright, well, what's the pattern on number 5? Plus 3. So if the first term is 7 and the pattern is plus 3, how do I get to the 15th term? Well, you'd have to add 3 over and over again. How many times, to get from the first to the 15th term, how many times would you have to add 3? 14. So you could just do 7 plus 3 times 14. That would give you the last term. So that'd be 42 plus 7. Any questions on that? There's a 14 term gap, so to get from the first to the 15th, you'd have to do this plus 3 14 times. So that will give you the,
3 times 14, like 42.
yep, plus 7. It's 49. Okay, this is 49.
Okay.
Alright, number 7, determine the number of terms in each arithmetic series. Alright, so the first term is 23. The nth term, the last term, is 55. Oh gosh, that's the hard one. S sub n is 351. I can't remember if our books use this notation or if it was just the algebra 2. Have we used that before?
No.
No. Okay, the algebra 2 books use it, and we kind of get the two mixed up. This just means the sum of all the terms is 351. So basically what we can do is just use the arithmetic series sum formula and plug in the stuff we know. And the sum is supposed to be 351. And then you can do a little bit of algebra. How would we solve this algebraically? You could add those two. You can multiply by 2 to get rid of that. That'd be like 702. And these two could add together. That'd be like 78. 78 times n equals 702. So you just divide by 78. Do you already do it? No? No. Okay, anyway. Must have added the first 9 terms. Okay. Alright, number 9 says a geometric series sum. So we're switching to the second formula, geometric series sums. And the first term is -3. Okay. Do you guys remember what R stands for? Yeah, it's the number that you multiply over and over again to get the next term. So, okay, they said a sub 1 is -3. A sub n is 65, 61. And the common ratio is -3. Okay, what we're missing is how many terms they multiplied. So we need to find the n right here. How could we do that? Okay, well, -3 is where we started at, and it's being multiplied by the common ratio n times, actually, I was wrong, n minus 1 times to get to 65, 61. Why is it n minus 1? For the same reason that this is 14. If you have 15 terms, you'd have to do the plus or the times 14 times, so it's kind of actually one less. This one's kind of a mess. We can kind of actually multiply those together. If you're multiplying the same base, what can you do with the exponents? Add. N minus 1 plus 1 is just n. So we could switch it to that. Now, how could we solve a problem like that? Log, that's right, good. So if the exponent's ever in the the variable's in the exponent, that's when you do log. And the log order is ACB. So A, C, B. sure if we did one exactly like that. This worksheet's a little bit different. A little bit different. If we didn't do it in the chapter, I'm not going to put it on the test. I will probably put some of these on the test though. Okay, number 11. Find the common ratio and the term, the net name term in the problem. Yeah, this is kind of easy. All right, what's the common ratio here? Times 3. If you weren't sure, you can just say 3. If it's complex, like a weird fraction, you can just do the second term divided by the first term. Or this term divided by this term. So, anyway, but yeah, to get from here to here is times 3 times 3. So yeah, that's the common ratio. And then they say, what's the named term? Which means they put a sub 11. So what's the 11th term? Well, to get from the first term to the 11th term, we would have to multiply by 3 how many times? 10 times. If you multiply by 3 once, it gets you the second term. If you multiply by 3 twice, it gets you the third term. Anyway, from 1 to 11, you'd have to multiply by 3 10 times. So it's negative 2 times 3 to the 10th power. That's what makes you multiply by 3 10 times. It would be a very large number.
Yeah.
Your calculator would give you a...
Yeah. Negative 118098.
Allison, are you tanner than normal?
No.
Just, I don't know. When I look through the classroom, it's like white, tan, white.
Okay.
Reddish.
You brought Sebastian landed.
Beyond white.
Yeah.
So white, you're red. See the blood. All right. Are you part Native American?
I'm Mexican and Puerto Rican.
Okay. Sorry, that's kind of random. Yeah, we already know that. Like 1 millionth Native American.
Eli's technically.
And then sophomore Eli.
Yeah.
Eli's Cherokee.
What percentage before they stopped counting it? That's what I want to know.
Wait, what are you again?
1/200 or something.
Do you mean what tribe or what?
No. His
Regular.
ancestors walked up.
Are you actually 1 in 200?
I don't know. It's still out there.
You think it's less than 1%?
Card. What? You have a card? My mom has it. I don't care.
Does the card say it on it?
Yeah, I think so.
That's crazy. Leo, I saw your mom at the gym yesterday.
Mom constantly, almost hits me when I leave the tech. She swings around that corner hard. Almost hits me.
She's a female.
Yeah. Don't take it hard. She can't help it,
I'll
bro.
talk about your driving.
Okay.
Leo. I see where you get the bad driving from.
Yeah.
Like actually an old Asian lady.
I'm going to show your mom this video. Okay. No. We don't see Leo's senior year.
Leo's gonna be cleaning the rest of the
Okay, given the first term of the common ratio, did you make sure I have an explicit formula? Explicit formulas. Okay. That just means you write the formula using n somehow. N represents what number a term you're on. So the first term is 4, and the common ratio is 4. Okay, so what we did, so if I made a list, it would be 4, 16, 64. Okay, the first term is 4, and you're multiplying by 4. So what we did on these is we backed up one step. So if the common ratio is 4 times 4, what would come right before this?
0.
Divide by 4. be 1. So you start at 1 and then you want to multiply by 4 over and over. How do we multiply by 4 over and over? Put a little in there. If we wanted to add 4 over and over, we would add 4 n times. If you want to multiply by 4 over and over, the n is in the exponent. But anyway, this would be the answer. How can we check this answer, by the way?
By seeing if it works.
Yeah, how do you see if it works? If you plug in 1, you should get this. If you plug in 2, you should get that. If you plug in 3, you should get that. So, anywho's. What number are we on? 15. Given the second term in the common ratio of a geometric sequence, find the term named in the problem. A sub 10. So, this means we're supposed to multiply by -4. How many times would we multiply by -4 to get from the first or second to the 10th term?
7.
No. 8. From 2 to 10 is 8 apart. So to get to the 10th term, you'd have to multiply. Common ratio means multiply by -4 8 times. How would I multiply by -4 8 times? I mean, we could do this technically, but what's the easier way to do it? Exponent. Okay.
I did it.
I just had an elementary flashback. One time I was sitting at my desk like this, and I breathed out my nose and it made a fart noise. And my friend was like, "Oh, dude, you farted." "No, I didn't." And I tried to do it again, I couldn't. Okay, something's a little bit wrong with this. You guys know what?
That's the second term.
It'd have to be like that. Because you want to, all of -4 needs to be multiplied, not just the 4. So anyway, whatever that spits out would be your answer. Okay, number 17. Find the sum of each geometric sequence. Describe. Okay. Oof. It's a tough one. Of course it is. We're at the end. A sub 7 equals 46,775. Okay, so the question is, what's the sum? So to find the sum for a geometric series, we need that stuff. We've got the first term, we've got the common ratio, and we have the number. Actually, I don't know why they did this. I take it back. Okay, so -3 would go in the, 3 would go in the first spot. And then what's the common ratio is 5. How many terms are we doing? I guess 7, because they list the 7th term. And then you just do the 1 minus r on the bottom as well. Okay, 19 is a little bit harder. What's the pattern on 19? Maybe they meant to. What's the pattern on this one?
+2 or times 2.
Times 2. So that would be the common ratio is 2. So the other thing we need is, let's see, that's all we need. So the first term, a sub 1, is -1. Then you do 1 minus the common ratio. The number of terms is 6, they tell us that. By the way, if this 2 had been negative, you would need to put that in parentheses. And then 1 minus 2 on the bottom. So you guys got that you need those formulas, right? They didn't put one for the final section, so let me make up one problem for that final section. I guess I'll just do the opposite of that. Okay, this is for an infinite geometric series. So infinite means it's going to go forever here. What is the common ratio?
Divided by -2.
Okay, it's divided by -2, which is the same thing as -1/2, multiplying by -1/2. Okay, if the common ratio is between -1 and 1, so like +1/2 or -1/2, it's going to converge. That means it's actually going to add up to something. Since the numbers you're adding are getting tinier and tinier, it's actually not going to add up to infinity. Even though you're adding an infinite number of numbers, it's going to slow down. You guys know what converge means? You guys know what converge means? It means come together. This is going to come together towards an answer. It's going to approach an answer. Like maybe 8 or 9 or 10 or something. So, because this common ratio is in this range, it does converge, and what it converges to, by the way, if this common ratio is not a fraction, a proper fraction, like if it was -2, it would not converge, it would diverge, which means the sum would not approach anything. It would approach infinity, or actually, it wouldn't approach anything, okay? So it's got to be here. If it does converge, use that tiny little formula over there to find out what it converges to. What is this infinite sum approaching as you add more and more terms? So it's really simple. The first term goes on top, and 1 minus the common ratio goes on bottom. What would this add up to? Oh, it actually would be going down, I guess. I think that's the answer. Yeah. A little bit of a mess. Alright, we'll call that good. Now, Leo, do you have your